Alright guys, so today we're going to finish up our segment on transversal angles. So this is part 3, where we're proving lines are parallel using properties of transversal angles. So first things first, we need to make sure that everybody knows that only some of these transversal angles can be used to prove that lines are parallel. Right? The angles that we can use, we're able to use them because their properties are true only if they are made with parallel lines. Alright, so that means that these properties are only true or will only work if the angles are made from parallel lines. Alright, so we're going to zoom in a little here. We're going to go through these one by one. So we can use corresponding angles. Didn't mark the little green one there. And that's not green. Right, we can use corresponding angles, and if corresponding angles are congruent, then we have parallel lines. Alright, we can also use same side interior angles, and if we have same side interior angles that are supplementary, we have parallel lines. We can also use same side exterior angles. So if we have same side exterior angles that are supplementary, we have parallel lines. Alternate exterior angles we can also use. So if our alternate exterior angles are congruent, then we have parallel lines. Alright, and our last one is alternate interior angles. So if we have alternate interior angles that are congruent, we have parallel lines. So we need to pay attention to both where the angles that we're looking at are located, so we can identify their relationship, and then figure out whether or not their property is true. So we have to figure out if they are really congruent or if they really are supplementary. Alright, so there are two angle pairs that we cannot use. Alright, and we can't use these because the properties apply or are true. Properties are true even when the angles are formed without parallel lines. And you can look at an example in part 1 where we go through the parallel and non-parallel version of these lines. Alright, so I'm not going to label them because we don't really need to know these properties for what we're doing today. Alright, I want us to focus only on these 5 angle pairs. And these 5 are what we're going to use to figure out whether or not we can prove that lines are parallel. Alright, we're going to go through 3 different examples. The first one, we're just finding angle measures that will prove that lines are parallel. So this is very similar to the exercises we did last session. So the very first thing we want to do is figure out the relationship. Alright, so I have angle 1 here and angle 2 here. So I'm on the same side of the transversal inside my parallel lines, which means I have same side interior, and I can look at my table, and same side interior angles are supplementary. I'm just going to abbreviate it. So supplementary means that if I take angle 1 and add it to angle 2, I should get 180 degrees if my lines are parallel. Alright, so we're going to figure out what this question mark has to be in order for those lines to be parallel. So I'm going to write 80 instead of angle 1 plus, I'm going to write in my question mark, equals 180. All right, and now I'm going to solve for what that question mark is. Cancels. This gives me 100 equals question mark. All right, so what this statement means is that in order for U and V to be parallel, angle 2 has to measure 100 degrees. All right, so we're going to look at a similar example, except now we have an extra line that we're not used to seeing. All right, so first thing I'm going to do is highlight these two lines that I want to see if they're parallel or not. All right, next thing, I have two lines here. I have this one that can be a transversal and also this one. So when we have more than one line that can be a transversal, we want to look to see where our angles form and with which lines. So if we look, we see that this 58 is formed with line U and this line right here that I'm putting in yellow. The other line here is not relevant, so we're going to ignore it. I'm going to put it in red and we're not going to take it into consideration at all. So we're looking at 58 degrees here. I'm going to make that our angle 1, and our question mark here that I'm going to make angle 2. All right, those extra lines are just there to distract you, so make sure you figure out which lines form your angles and only pay attention to those. All right, so now next thing I have to do is figure out my relationship. I'm on opposite sides of my transversal. So this is my transversal, which means that I am going to be alternate, and outside of my parallel lines makes it alternate exterior. And these are congruent, which means that my setup is going to look a little bit differently. I'm going to have angle 1 equals angle 2. So I have 58 degrees equals my question mark, and that is my answer. So that means that in order for U and V to be parallel, angle 2 has to be 58 degrees. Easy. This is very, very similar to what we did in the last lesson. All right, now we're going to take it up a notch. So now we're finding values of x that prove our lines are parallel. So very similar. Now we're just solving for x. So I'm going to do the same thing. I'm going to label this angle on top angle 1 and the one under it as angle 2. All right, I have them labeled, same side of the transversal. Inside my parallel lines makes it same side interior, which is supplementary. So angle 1 plus angle 2 is going to equal 180. Didn't want to pick the other color. Equals 180. There we go. Now I'm going to take my numbers and plug them in. So I have angle 1 is 12x minus 5. I'm going to bring down my plus sign. And then angle 2 is 15 plus 5x. And all of this equals 180 degrees. Alright, so I'm going to pick two colors. Let's do orange. So all the terms in orange I'm going to add together, and all the terms in blue I'm going to add together. So 12x plus 5x is going to give me 17x. And then I have negative 5 plus 15 is going to give me 10. and all of this equals 180, and now I have a two-step equation. I'm going to subtract 10 from both sides, which is going to leave me 17x equals 170 degrees. Divide by 17 on both sides, and x equals 10. So this means that in order for line U and line V to be parallel, x has to equal 10. Alright, we have another problem with an extra line. So we're going to do the same thing we did before. Let's go with this yellow highlighter again. So I'm looking at line U and line V. So we have two extra lines this time. So anything that I put in red, we're not looking at all. So this extra line up here, we're not looking at it. We don't care about it. It's not contributing anything. And then we also have one line going up and down and one kind of going a little bit slanted. But if we notice, this slanted line isn't giving us any useful information, so we're also ignoring that line. So now we have angle 1 here, which is 45x, and angle 2 here, which is 46x minus 2. Alright, I'm on opposite sides of my transversal, which is this line here. That is not the right pen, there we go. That is my transversal. And inside my parallel lines means I have alternate interior. And alternate interior is congruent. You can look at your table, or you can just remember, because this is the third one we do. Alright, so that means that angle 1 equals angle 2. And now we're just going to set up our equation. So angle 1 is 45x equals 46 minus 2. Alright, so we already have x by itself on one side, so we are going to move our other x to that side as well. I'm going to subtract 46x, which is going to give me a negative. So 45 minus 46 is negative 1x, but we don't write the 1, so we're just going to go x equals negative 2. So we have a negative x, and I don't want that negative x. So I'm going to divide by negative 1 on both sides, because a negative divided by a negative gives me positive x, and it is also going to give me positive 2, and that is my answer. So in order for line U and line V to be parallel, x has to equal 2. Alright, pretty easy. It's a lot of applying what we learned last week to a new context. Alright, this last example is going to be a little bit trickier than the last two, but I'm going to try and break it down as much as possible, so stick with me. Alright, so now we're going to use angle measures to prove that lines are parallel. Alright, so we're going to look at this image first. So we have 4 lines, and we want to figure out, based on the angle measures that they give us, or the congruency measures that they give us, which angles are which lines are parallel. Alright, so first thing I'm going to do is go through. So if we have one arc, that means that this angle and this angle are congruent. And if we have 2 arcs, it means this angle and this angle are congruent. Alright, so when we have an image with more than 2 lines that could be parallel, we want to break it down so that we can see the different scenarios that we have. Alright, so that's what I went ahead and I did here. So in this example, I said that line G might be parallel to line H, and line J would be my transversal. All right, so let's label that. This is my transversal. All right, so now if that's my transversal, I have to identify the relationship between these two angles. So again, this is my purple angle and this is my blue angle. So I am inside of my parallel lines because I said G and H are my parallel lines, and opposite sides of my transversal, which I said was J. So that makes them alternate interior angles. And alternate interior angles have to be congruent. So we don't have any angle measures, but we know that these two angles are not congruent because they don't have the same number of arcs. So because this statement is not true, then line G and line H cannot be parallel. And I'm just going to use our abbreviation for parallel. All right, so we're going to try a different scenario now. So now in this example, line J here is parallel to line K, and line G is my transversal. All right, and I have both of my blue angles. So now we have to figure out the relationship between the two angles that I have here. So I am on the same side of the transversal. I have one interior and one exterior angle. So I have corresponding angles which have to be congruent. And because I have one arc for both and one arc, that means that my angles are congruent. All right, so that means that line J and line K are parallel, which means that this statement is true, and line J is parallel to line K. All right, and that would be my answer. So you're going to see this in multiple choice, so you want to pick the choice that gives you the two lines that are parallel. All right, we're going to do one more example here, and this one's just a tiny bit more complicated because we have more lines. We have angle measures now, so we don't have to look at the number of arcs, but we still have to apply that relationship. All right, so I have 5 lines here. They're drawn as avenues, but I just wrote the letters. So in this first breakdown, I said that line A and line B are parallel, and line C is my transversal. So let's label that transversal. All right, so if line A and line B are parallel, we're going to have to do a little bit of figuring here. So I don't know the relationship between these two angles, but I do know that these two angles are equal because they're vertical, and now I can analyze that relationship. So I'm on the same side of the transversal inside my two parallel lines, which means I have same side interior, which should be supplementary. So I can check that really easily. Let's make this angle 1, and 100 is angle 2. All right, so if they are supplementary, if I take angle 1 and add it to angle 2, I should get 180 degrees. So let's check to see if that's true. So I have 50 plus 100 equals 180. So 50 plus 100 doesn't give me 180, it gives me 150. And we all know that 150 and 180 are not the same, which means that this statement is not true. So line A is not parallel. Not parallel to line B. Alright, that's fine. Our first try didn't work. We're going to try another set of lines. Alright, so in this second example, I set it up so that line C is parallel to line D and line A is my transversal. Alright, so here I have the numbers 50 and 80. So we're going to have to apply our properties of linear pairs. So if this is, because we know that linear pairs are true even if our lines aren't parallel. So if this is 50, this angle here would have to be 130. And then we would have same side interior angles again, which means they would have to be supplementary. Which means if I take 130 plus 80, I should get 180. 130 plus 80 gives me 210, which is more than 180 degrees, which is also not true. Alright, so line C is not parallel to line D. Alright, we're going to try again. So now I said that line C is parallel to line E. Alright, and line A is my transversal again. Alright, so now we have to figure out our relationship. So I'm on the same side of my transversal, and outside of my parallel lines makes it same side exterior. Alright, which is again supplementary. So that means if I take angle 1 plus angle 2, I should get 180 degrees. Alright, so I have 50 plus 130 equals 180. So 50 plus 30 gives me 180. 180 equals 180, which is true. Awesome. So that means that my lines that are parallel are line C, and so line C is parallel to line E, and we proved it up here. So I'm just going to write a check mark there. Alright, this may seem a little confusing, but you just want to take it. You can draw it out again if you need to. But you just have to apply different properties. And remember, we're not looking at vertical or linear pairs to prove that they're parallel. We can use their properties to figure out other angles, but we can't use vertical or linear pairs as our justification. Alright, so I will see you guys on Thursday, and your assignment is up on Google Classroom.